Hello, everyone, and welcome to the broadcast. We're going to be continuing our game dev project today. We got the skeleton of maps working last time, and we're going to expand on that in a couple of ways today. But before we get into that, let's check in with the kitties. We do have Ember on the side table here. I looked at her. Hello. Come on. Come here. Yeah. She trills in response if you talk to her. She has jumped up on my headrest. So let's see here. We have Mason on the bed, Sammy in the play area. We can see Sky in his in the food area just a little. We can see his pattern for eating, where he will he only eats after he has killed the kibble on the ground. But yes, dev today. Okie dokie, let's see here. So I believe we still have the basics of the map tile hackery we were doing last time. See, we are joined by Adrian over there on the tall stream. Hello, Adrian. So we can see we've got the variations of patterns in. The little ring of them demonstrates that we don't have the whole tile sheet configured yet. So you can't see like a ring. You can't see any of the other patterns, but we'll get those in there. We did stop before we got entangled too much in, and hello, Adrian, welcome. We did stop before, or it's Ardian, okay. Ardian. We did stop before I got too deep, too much deeper in the sprite, the tile sheet configuration, like its layout. We've still got to revisit that because it is part of the loading process where we have to say this part connects to these parts. This is a gigantic ugly collection. It's better than the gigantic ugly if/switch statement. But this is how we have to define it. This square on the tile sheet is used when it is adjacent in this way to other squares of the same terrain type. Terrain in this case being the Godot terminology for a set of tiles. It often gets used as, map terrain, like this is a dirt tile. So it's an accurate word, at least in how they use it. Today, what we want to do is get a little further in this construction in two ways. We are going to set up a default map layout, like a pattern for it for now, such that we can tell when you enter or leave. Learning to code is difficult or easy. I think learning to think in code is the hard part. Is the harder part of the two. So, let me think how to put that. It's once you've learned to think in terms of consecutive statements that do only what you're telling it to do and precisely what you're telling it to do, and then organize those into a flow of instructions, then the actual learning to code in a particular language is just an extension of that. It's easier to learn languages once you've got the basics for doing it. So with that in mind, coding tutorials and figuring out, okay, do I understand what's going on? Can I see that? And that's what you're learning, is finding things that describe to you how this flow works, and do you grasp that? If you do, or you want to learn, then you continue. If you find this isn't for me, then you stop. But I would say it's easier than some folks would think. Now, I want to code a Unreal Engine, multi-A caliber shooter title or something like that. Well, okay, now you're getting, that's the deep end. Wading into the pool at the shallow end, though, that's pretty straightforward, and that's where you start. Do not dive into the deep end. There are horrors in the depths. Okay. So, an example of what I'm talking about is getting the idea of things like iteration and what you do within it. So this is saying, for each row and for each column in that row, do this thing. And there's an added limitation that once we're out of textures to work with, once we're out of the things we're working on, we stop iterating on rows and columns. Okay, what do we have to do? Okay, let me get another tool out here. And I'm going to do this with the camera off, or the screen off, for a moment, so I don't flashbang you with the load up of this program, because it loads up with white on a very dark background. Okay, so put you, no, it doesn't have that hotkey. We put you there. That's weird. Put you there. Open up layers, make a new layer, and we're back in. Okay. So, what is frequently the case with these kind of games is, whether it has limits or not, you have a box somewhere that represents the world. Again, you can have this extend forever, and I would like you to actually, there we go, hotkeys. And the player can move in any direction we want. We have, let's give him a little dot here. We start somewhere in the world, and the player can move anywhere they want in that flow, including coming back. And one of the difficulties that I have with this pattern is that it's prone to creating a bubble that you live in for periods of time. I go here, I hang out here. I go here, I hang out here. In fact, the stronger the player gets, the further into it they get, the more incentivized they are to hold still. And I would like to avoid that. It is what leads us to things like, most of these games have a pickup range bonus of some kind, and that is one that can often feel mandatory, because the movement that you're doing is generally to get to the pickups and nothing else. If it weren't for the pickups, you would just sit as still as possible and only move to dodge a projectile. Now that's in a In a lot of games, it is better to hold still than it is to move. You can't run into an attack if you're not moving. But it creates this gravitation where I want to stay within the bubble and only move to pick up the power-ups. I would like to get away from that pattern, and one of the thoughts for doing that is, let's say that the game world is instead a corridor, your classic like side-scrolling brawler kind of pattern, where the player has to move difficulty when I learn to code. Is there another way so I can learn quickly? Frankly, the best way to learn is tutorials. There are really good ones out there, and they're usually focused for purpose. So, for example, when I was starting Godot, they have a good little sample project that gets you the idea of the toolkit. It's finding things like that. Generally, for programming, the first thing is often called a Hello World project, where you figure out how to accomplish a basic flow and iterate on from there. Can I find a more complicated tutorial? It's a lot like learning to draw or anything like that. There isn't really a shortcut. Learn functional thinking. Learn how to convert an intent into a series of instructions or a logical structure. So I need to do this 10 times, so we're going to do this thing 10 times. Okay, I can just do that consecutively 10 times. Then you learn things like, well, I can do a loop where instead of repeating the same command 10 times directly, I iterate over it. It is learn it in sequence. But find tutorials. If you want to move faster, find tutorials, and at the end of each step of it, ask, do I understand what they're doing? Because if it's a good tutorial, you're going to learn why they're doing as much as what they're doing. I'm trying to drink the beverage, Ember. I am. I have a cat on my shoulder. Okay. The player is forced to, and don't worry, I do watch for chat. Feel free. The coding portion is in stream of consciousness. If you have questions about what I'm doing or why I'm doing it a particular way, feel free. I do not expect anybody watching to be an expert in code or Godot or anything like that. In fact, you'll find people much more expert in code than I am. Assuming you are not, well, assuming you are being polite in chat, I have no problem stopping to converse and talk about whatever. But otherwise, you're hearing me thinking. Okay, so if we present it this way, where the world is a long rectangle with the... Welcome back, Ahmed. What we are doing this time is we're working on our game dev project. And we're looking at how we present the game world. We got the basic structure for drawing the map tiles. And now we're laying out the structure of the world. One of the things I was just mentioning was that the basic pattern for these games is to have some sort of world in a box. You have a playing field, whether it extends infinitely or if there is eventually a boundary, it is an area to move around in. I apologize. I am I have been told I speak very formally sometimes, which ideally doesn't lead me to use words I don't understand, but it will lead me to try to use words that I feel are more precise, and that can lead to more archaic or bigger ones. So in bullet heaven style games, your Vampire Survivors games, generally you have a open playing field where the idea is that the flow of enemies and your movement is in 360 degrees. You move wherever, but primarily you move only when under direct attack, so under direct threat, and when you want to reach a pickup of some kind. And that's why we tend to have things like XP orbs or something like that, little gems or something. You have to pick up in order to get upgrades. That encourages you to move. It is the driving force to move. But that leads to some games having things like pickup boosters. Because as the levels progress, moving around gets harder or more dangerous. So moving to try to pick up that little gem on the floor in the middle of swarms of monsters is contraindicated. You want to avoid that. Additionally, speed boosting upgrades are often things that you want to be careful about, because moving too quickly is generally overshooting those pickups and potentially slamming into enemies. I would like to avoid the idea of speed boost things, the player moving too much faster, because I don't want that sort of, am I going to move too fast if I take this power up kind of concept. And I also, though, don't want this feeling that I want to mitigate the need to move. I want to remove the need to move. Rogue Genesia has another bullet heaven game in the vein of Vampire Survivors. Vampire, haha. Has an upgrade that's like Void or something like that, Void Elemental, something along those lines, that says as soon as a power-up drops, it is automatically pulled to you. So you don't have to move to pick up the XP. At that point, unless a enemy forces you to move to avoid damage, you don't move. Whenever possible, there isn't a reason to move at that point. If I change the flow here, and it is not unique, I'm not claiming that this pattern is unique. In fact, Vampire Survivors does have narrow levels. We are hexproof. We are making a game. We're making a Vampire Survivor style game. This is the rare diagram in which I try to explain my thought processes. This is largely we're coding and designing as we go. I've never made a game before. I have programmed extensively in the past. Again, I'm not by any means a fantastic coder, but I have done so professionally. So I have some knowledge. But we're all kind of learning together. I've never used Godot before. I've never made this primary language my target. So even though some of these games have narrow levels like this, we're looking at it differently, or I'm looking at it differently, and that the player's goal per level is to get from A to B. It is not to survive as long as possible. It is to get from A to B within our time limit without being defeated. Then, along the way, we can have things like checkpoint lines, where if I get here if I get here, we can have some sort of bonus for getting there. Additionally, we can have things along the way. Yeah, let's use little circles. Ooh, little diamonds. I can have things along the way that I want to get. What those things might be, that's not yet determined. But what I want to do is have the player incentivized to move in ways that will take them to the objectives as they go, the sub-objectives, as well as to continue along to our goal. Now, we allow the player to move backwards a little bit, but there is that hard boundary in place that says you can't go back any further. So this, as you go along, extends forward and creates new barriers. Now, I would like to represent this as something that is a mobile threat. We're not going to auto-scroll. This isn't a shoot-'em-up, a genre that is largely gone missing. Traditional bullet hells are often shoot-'em-ups. Your Toho games, it was Ikaruga or something like that. But it's not auto-scrolling, it's that you can't go back. Your Mario Brothers kind of games. Not your 3D ones, the traditional side-scrolling ones. You can't backtrack too much. So once the screen slides forward, you're still stuck on the screen. What that means is additionally, I can have our enemy flow coming from this way. And that can mean they are coming from the sides of the screen, they're coming from up and down, they're coming from behind you. Because the goal is not to wipe out the enemies, wiping out the enemies is part of the process of getting to your objectives, getting to your power-up points, that kind of thing. That means that the enemy flow is a thing to be mitigated and avoided. So let's show where we are right now. As is tradition, I must show off the core mechanic of the game. Loading. We have our pest tile map in place here. So, if you're familiar with Vampire Survivors, you know that every time you level up, you get some sort of upgrade, whether that be an upgrade to the character or it be an upgrade to a weapon, but these are known fixed upgrades. If I take another, if I take another torch, my projectiles get this much bigger. If I think it was a torch, it's the candelabra. If I take another armor, I get more defense points, exactly this many. If I take an upgrade to this weapon, this particular upgrade gives me this particular benefit. That's not what we do in. It is a modular upgrade system. So the yarn ball behaves in a fixed fashion. Again, the yarn ball is not a great example. Currently, it is incomplete. And the way it moves is not good currently as a result. But it will demonstrate things like stuff can move on a z-axis. What it amounts to is if you're in the air, you can't hit things. But if a yarn ball is on the ground and it collides with the slime goes away currently. But that's not necessarily good enough by itself. So we're going to demonstrate with some overpowered modules here This is going to produce 9 times the yarn balls here. We fire in a burst of 3 over 1 second, and each projectile splits into 3. It processes left to right. It doesn't matter that these are... The order of these does matter, but you can't see it. So now we're emitting many more yarn balls. We're currently sitting at about 200 things in the world, as well as about 500 frames per second being processed. We're not looking to keep that frames per second. We're looking to keep it above 60. Okay, so we're still not hitting a lot of things. Let's change it so that we get a little more control. We're going to make it orbit around the player. So now we've added a movement change. And what a movement change means in this game is that in addition to all of the movements that have happened before this change, and the starting with the base movement of the yarn ball. Yarn ball's base movement is to target the position of an enemy at the time that it spawns. It's a random enemy, and it moves towards that. So, in Vampire Survivors terms, your... Oh, what is that weapon? The Fireball Wand. Pick a random enemy, fire at them. But when it does that, we're also saying try to orbit the player. So, in addition to that initial movement, we're causing it to loop around. That loop around movement technically speeds up the projectile. Not all of them will speed up. For example, this movement, which makes it move in kind of a loop-de-loop, slows it down. Because its path of motion is much longer now. But we can see now they're kind of moving in circles as they fly out. We can do things like a wave motion. You'll notice that there's like a little burst happening under the player periodically. So by itself, that is periodic damage around the player. Your garlic kind of effects in Vampire Survivors. Somebody, Hexproof, has mentioned that they're familiar with that. I'm going to speak in terms of that game. While the genre did exist before Vampire Survivors, it is the one that caused it to kind of take off recently. And recently in terms of years. But it doesn't do a lot. This is not a weapon that I want to have in the game because you can't really modify the explosion. But it serves as a good test for us because we can do this. This is a power-up that consumes the next weapon and makes it part of the prior one. So now, after 3 seconds... the yarn balls are going to start exploding every second as they move. So we can see those little pops going off. I think that's Mason there. But yes, Mason is cozy. And hello, Tess. Welcome. They look very similar from a distance. Sherbet is currently scuffling with Molly by the door here. He has slightly the high ground. Just checking something real quick here. Okay, we still have the stall. I thought I fixed it. Boo. We'll work on it further. Anyway. I was talking about the flow of gameplay here, and this be the diagram. So we have a you can't go back kind of barrier. Whether that is a physical barrier or one that slowly creeps forward, I don't know. But it will be something that you can't go back past for whatever reason. Player proceeds to the right. End of the level is all the way to the right. As long as you get there by the time limit, you complete the level and move on. Throughout the course of it, we have two things. We have little micro objectives. I don't know what those are going to be, but these encourage you to move in not a straight line. There are things that you want to pay attention to their existence and go to them. Additionally, some sort of checkpoint, something that you want to reach, and you will get a bonus of some kind to reach it. Kind of that way. The idea, it is a thing to force you to move further. So the mini objectives, the checkpoints, and the encroaching barrier are things that say you need to move to the right. All of that is saying move, keep going. This simplifies the flow of enemies and gives us really good patterns for them. Things can strike in every direction towards you, but because you don't have infinite movement in every direction, you need to react to them. So again, we can do a lot of patterns that are things that you would see in shoot-'em-ups. So the enemy moves from right to left, top to bottom, something like that. Maybe they move with slow homing. That kind of thing. So this is the thought. Now, we're just adding layers arbitrarily. To accomplish that, in game generation terms, so to render the map to the player as they go, Ember has come to join me. Molly joining the family, the cats. Oh. Molly joining the family has really made Sherbet more sociable because Molly will play with Sherbet. They both have a lot of kitten energy still. Let's see. What did I change that to? There we go. I need to rename that button. Molly is getting a drink. Molly is getting chubby. Her natural shape is a little rounder. She's a bit egg-shaped, but she is also getting a bit of a belly flap now. So there is increasing chunk in Molly. Sherbet is somewhere behind her currently. And we'll put it back to Sky. So if we look at this, we're going to say, oh, no, not that. We're going to say the player is currently in this box. Then the next box is here, and the prior box is here. And as we move, we're going to snap boxes forward. We're going to take boxes that are out of range for the player to enter. So I would probably have another box over here. And as soon as I enter another box, I snap one forward, snap one forward. Mitigate the amount of loading and memory that we need to keep up. What this should do is say there are no more than, let's say, 4 boxes in existence at once. You have the next block down the road, and we have the prior block that I'm still able to enter by backtracking a little bit, and the block that can now no longer be entered because it is behind the movement area. We might be able to get it down to 3 boxes, where as soon as I can't see the last box, we snap it forward. I'm sorry, as soon as we can't see it and it is behind the no-go zone. That is a bit of juggling that would need to be done. Mason has come out for back scratches. I'm juggling cats right now. I was getting some full-on high energy cats earlier at the start of the stream. But for today, we're shooting for the visible boxes. So what we need to do is have it where we are loading boxes into the map renderer and saying, these are the things that we're doing. These are the boxes that are visible currently. Now, for the purposes of the map renderer, it should have a cache of things. It will have X map elements that it's keeping so that it can reuse them. We need to have a way to tell the world how to place those map elements properly. And I believe I have some patterns for that. But the map renderer is going to be the one that's responsible for saying, this thing is out of range. Hey there, Dorothy. Welcome. Ember. Ember is being demanding today. Not just her normal, I would like pets right now climbing onto my shoulder, but trilling at me on my headrest and batting at my hand if I reach to pet her incorrectly. Let's see. She's probably going to jump out of range in a moment, but oh. So both hands cat occupied. Mason is down and right from me. Ember is on my headrest. Sky and Sammy are both within range. Let's show the ones we can see while I am detained. Just a quick thought here. Again, while I am detained, I'll turn that on and see if it helps. Let's see. So, Sammy on the table there. Sammy and Ember are a bit rival for my attention. Ember likes to be on my shoulder or my headrest. Sammy will come over to sit on my lap. Currently, Sammy is doing the I'm not thrilled with you, but I'm not so unhappy that I'm going to leave thing there. She has actually got her back to me. So, I am not disfavored enough that she refuses to be around me. But I'm not favored enough for her to seek attention or to merit her attention directly. After a while, you learn with a cat when the body language says, I'm paying attention to something else, as opposed to, I am not paying attention to you. It's that I'm not speaking to you difference, you know? Ember's high energy, you could see the waggy tail there. She slightly resents the fact that Mason is getting back scratches down there. Oh. Okay. So, puzzling out that flow, these lime green boxes here, to how we can properly manage them. One thing we could do is that we rely on the map renderer entirely to display only the current boxes. So as we progress forward, a world manager tells the map renderer, now you shall render this box, and puts it there. We can either have a world manager subsequently remove the boxes that are too far away, telling the map renderer to clear them, or we just have a pattern for how to manage them. So, for example, we could have something that represents a chunk on the map. And we tell the map renderer, show this chunk. Or load this chunk. The map renderer can be told, could manage the chunks itself, but we could also have a world manager that says unload or remove this chunk. Or cease showing this chunk. You don't need it anymore. We'll see. We'll see. Think. I think the idea of a map chunk is where we want to start. So let's go over here and show... How would we do this? What this says, what this goes through is to say, use this one if all are filled. That's what this does. So we're gonna pull that out real quick and make sure that I haven't broken it. I just got distracted. I saw that and couldn't remember why I would be doing that. So I want to make sure I get rid of it. Because we don't need it. If I don't get rid of it if I hadn't gotten rid of it when I saw it, I might forget that it's there. So let's... save that. Rain tiles. Okay, so this is us loading in information about the terrain. So we are getting them loaded, saying this is part of this terrain set. It is part of this terrain. We currently only have the one terrain set. We update each tile as we go along for that. This is our Godot tile set. we create the whole tile set. We are going to add terrains to it. Each terrain, so there is a terrain set here, which will always be 0. Again, there is a fixed one. We say that we account for corners and sides instead of just sides. You know, cardinal and intercardinal directions kind of thing. We are going to go in and say for every one of the tile sets, or the tile sheets, we are going to have one terrain. We say this is the atlas for it. This is where the tile images come from. And we get that. So set tiles is where we're making them visible. And currently what that means is a list of lists. It is a two-dimensional grid where we say which terrain we are going to put at a particular spot. If just messing with stream settings as we go. Hey there, Cal. Yeah, we are moving along. Things are going well. Hope things are going well for you too. Haven't seen you in a bit. Okay, so this is we found out that we were doing it completely wrong thing. Okay, so this is us going through all of the terrains that are contained in the list of values and setting them in. I heard Sky was thinking of going to a convention of some sort. I don't know if that was on your schedule as well. Where is it? That's right. Is he doing okay? I saw a post about that. Oh, 2-hour drive. I don't like long drives at all. Driving, I do not consider to be a fun thing. We're not spiking anything. I don't want to mess with that too much. I'm having to mess with a couple of things. We're getting closer to a fix for something, and I'm hoping that we're gonna get there. It's better, but it's still there. We'll see how it do. It is something that has been bothering me, and I'm trying to fix it. If you watch, you can see the model hitch periodically, and I don't know what doing it. Anyhow, this is the part that we found out we were doing very wrong. This is the only call we need to make to set a tile. Well, it's, there's footwork to set it up, but we say, okay, all of these tiles are this terrain. Makes sense. Makes sense. I try to find videos that I can listen to as well. Now, I still like to sit down and watch videos now and again, but having ones where a majority of the content is what they're saying is good. And hopefully those, hopefully whatever's plaguing the doggo, the meds or whatever you end up needing to do will work. Okay. So these are the 3 textures that we're essentially saying manually load these right now. So this is going to be... We're either looking at loading all of them, which I'd like to avoid because we don't know how many map textures we'll have. Yeah. Could be something either in the environment or, food or any number of things. But again, hopefully that'll resolve. We're creating the atlas. We're stitching all of them together. Okay. So right now, this is how we're hard coding what the map look like. I do need to set up a map editor at some point, something that I can use to visually create or paint the map. Now, I could do this by having some sort of pattern to define this color is this world, that is this terrain, and the map contains the terrains in the right order. So that I can define that cleanly. That is, I would go in and say this terrain is this color, this terrain is this color, and then I could just have a bitmap be the map at that point, which could make terrain editing pretty straightforward for now. And I could define a world map as a series of chunks of bitmap. We would need to define how to render a chunk. You see the same kind of concepts in things like Minecraft. There are portions of the world that get loaded and unloaded as they are needed and unneeded anymore. So I think that might be something we pursue there is stuff and things. Whoops. Boop. About... We'll see if that do. Probably not, but... yeah, it's still hitching. It does look like I'm spending a lot of time trying to debug the model, vtuber scuff on stream, but additionally, I'm doing a lot of this off stream too. I don't know why it started happening. I have updated ever so many things. It is better. I feel like there's some sort of graphics driver issue at play. But anywho. Okay, so we set up bitmaps to represent map chunks. We tell a map, we create a map object that has a pairing between terrain objects, a terrain object being... Yeah, it's weird. It's weird. I did switch the drivers that I'm loading, and that has helped. It doesn't hitch as long, but it still is clearly hitching periodically. It is something within VTube Studio. Something about it is causing that hitch now. I know they had their recent update was causing some crashing issues as well. Might have to try. I'll keep trying stuff. Anyway. Okay, so we need to pair textures that represent tile sheets with colors for a map chunk. I'm sorry, for a map. And then each map chunk will use those colors, will be a bitmap with those colors in play to create that list. We can then translate a bitmap when we're loading up the map into the equivalent of this, where we are iterating over the bitmap and converting it into a list of numbers. This might be another good pre-processing thing. Hey there, SciTech. Well, I presume if you're saying higher quality model, that originally you saw the old Catbot model as opposed to the Nyanite model. And it's that, if that's the case, yes, indeed. Okay, so we need processing on a bitmap now. So this is the Nyanite model. The Catbot model was the gray boxy TV screen looking guy. Okay, so... So we load a bitmap, we parse the colors into terrains. Okay, so terrains are loaded in to a map atlas based on their order. We could hard define that, where instead of loading a terrain as a number, as a sequence, 0 through 5, we're going to arbitrarily say this is terrain X. because then we could have so we have a terrain number, we have a texture key, and a color for it. So we say if you encounter this color, you are going to use this terrain ID, which corresponds to this texture key. So we load this texture key, and we put it in our set, and we pair it with a terrain number. Well, we essentially have a triplet here. And we need all three of those. But we could just put those into a list. Then when we're iterating over it, instead of where we add terrains for each of these this way, we would have we can give it a list of terrain numbers to use to go with the atlas. And in the same way, when we are loading the tiles for a given terrain, that is going to be passed in for the corresponding terrain value that we need. Same with peering bits. Right here. So right now we're iterating. And we're just saying terrains in sequence. What we need to do instead is pass in a list of terrains. We're still going to iterate on the terrain, but instead it's going to iterate on a list and grab the next terrain in the list as it goes along. Okay. We're getting there. We're getting there. All of this stuff, for those that are joining and aren't familiar, we're making a game. We have a lot of the skeleton of play in place. We're not going to do the full demo of behavior, but player exists, player emits projectiles aimed at enemies or doing some other thing. What we want to do is, to begin with, create a world that is a sequence of left to right map chunks for the player to move through. We'll get bounding boxes that the player can't pass into, that kind of thing, soon enough. And the enemies would normally hurt the player, and the player goes away if they run out of hit points eventually. But I have turned off their ability to hurt you. All things in the game are controlled by a sequence of events. For example, I mentioned that I turned off the way that the blobs hurt the player. That is an event. If the blob collides with the player, there is behavior in the blob to say, inflict harm on a thing that I collide with. And blobs can collide with the player. Blobs are just a placeholder enemy for the time being. I started with them because I came up with a sprite for them and I felt it was cute. We are going to use it. It's just not yet. No, not in the beginning of the game. We need to come up with other things to use first. But we're going to get this map chunk loading thing. And that is getting this these tiles to be set into the world. So for this, when we're coming into this function, in addition to a list of textures, we could just have a list of, like, we're getting textures, current texture. It's just a list of texture IDs. We could have this collection that I'm talking about, where we have a terrain, a key for a texture, and a color, so that when we're loading it in, we're taking that texture. It's not even a texture that we're loading there, though. That's a texture wrapper. We could still do that, though, because, yeah, this is a texture wrapper. So we're going to have that list of terrain to texture wrapper to color. We'll have to figure out a good way to load that from the files, but that might just be an object in and of itself. Okay. Because we need, in order to load this properly, we need to create the terrains here. But instead of textures count, we're going to pass in that listing again. Okay. Thought process active here. If you got questions about what I'm doing, folks, feel free to ask them. Coding Stream does not require my full attention, and I'll be derailing myself as often as chat would prevent me from coding as well. So don't worry about doing that. But that said, we are going to take a quick break. And we're back. Okay. So let's look at our map idea. So currently, the idea of a world map is a texture by itself. We're not going to be using this concept. I feel like our shader renderer is still a valid idea. So I don't want to fully break it, but that might be necessary. That might just mean that we effectively rip its bits out for now. I have... yeah. Okay, so I have a level which has our world event list. This is what spawns and when. We have our message handling. A level needs a map to load in. We currently don't have that. That map is the thing that we're going to edit next. Okay. Hello, Sky. Yeah. He's snoozing and watching me. Give him a little slow blink in return. Okay, how we do? How we do? So call you a world map chunk. Ember. Yes, I know. Ember is being very squirmy today. Okay, so we have a world map chunk. I think this is one that we don't need to load from a catalog because you're not going to reuse a map chunk. So we have the bitmap here. That's pretty much it. But then, do I even need the world map chunk? If it just contains a bitmap, I don't really care. But we could use this as a way of converting the bitmap into its list, because I don't need the bitmap so much as I need. But the world map chunk won't know what the terrains are. It is the world map that defines what the terrains are and what the colors are. So this is ultimately just a bitmap, so we don't actually need you. Okay, so we need... yeah, I know. Nuisance. Ember demands extensive attention right now. You are being extra squirmy, ma'am. So it has a list of bitmaps that are the terrain chunks. It has a list of We could also have a... I think there's a flaw in my keyboard. The I is randomly double tapping during typing. Again, it could still be that I am, like, my finger is twitching over that key when I'm typing I. But it's... the inconsistency is odd. So if we do this, that's fine too. We're going to need to find a way to properly represent this. Because this could be an object that is a color value, a terrain, that kind of thing. Because this is an integer, a color, a C# color object, and then a key to a texture wrapper. It's not a long list, and world map is likely to be something that we're going to have to do individual JSONs for. This is fine. Sequence. This is the texture wrapper for one of our terrains. This is its ID number. Inside of a map chunk, it is this color. Here's our list of bitmaps. Once we initialize, we want to convert our list of bitmaps into a list of grids of terrain ideas, because we don't need them as bitmaps. Ideally, I would not save them. That I would read the file and parse it in, because I don't need them loaded into memory. This structure would keep very trim if I don't have the bitmaps. It is not end of the world for me to keep them, because I'm never calling to render them. So there's not going to be any graphics card song and dance. They're also not going to be huge. So for the time being, we'll leave that alone. Okay. Tile size we don't care about. Same with tile height. That is going to be a fundamental element. We will need to find a place to cleanly set up the tile size, because that can't be inconsistent. Whatever we define a tile to be is what a tile is. Okay. The texture atlas is handled by the renderer. Same way, we don't need a map texture. So for our shader, we are going to preemptively go into our map rendering. And we are going to gut this thing out. That's okay. We set world map. We will do nothing there. During an update, we will do nothing here. I'm doing this to avoid compilation problems. Wow, you got toasted there, Sky. You toasty? Yeah. I have to figure out, I haven't been able to, where are the kitties gone? Let's find them. Let's try to find them. Yeah. Yeah. We'll have a good view of Molly here. She's a little sweetheart. One of her shows of affection is the circle around your feet, flop down, and like grab at your socks or similar. She likes to sit at your feet if possible. Okay, so that should be fine. That should be fine. We're going to do a quick build. Okay. Map shader render needs to get a update in order to work properly. Save that yet. Or that. We are going to need to revamp how the shader renderer works in order to get things functional. Yeah, brah, I can use the extension here. I haven't taken the time to figure out how I want to do that. I'm just familiar enough with this pattern that I can use it. But yes, it would largely be the same thing. Okay, so that's our map shader render disabled for the time being. And then our world map needs its updated bits. Yep, there is merit to that. But again, I would need to sit and learn that pattern, and I just haven't done that yet. We're probably going to need... We could load them as textures. And if we load them as textures, then we can use texture wrapper and dodge new structure, since this is a catalogable. If we create parallel collections, we don't have to worry about having a special triplet. We are going to need to have... We might turn them into key value pairs for particular function use. But we'll see. We could also just define it as a dictionary of texture to terrain number, and then a dictionary of terrain number to color, because the color is only used for the processing of the bitmaps, which will happen once. Okay. Okay. Because the color is just for translation to a terrain number. And the terrain number and the texture wrapper go together. It will mean that there's data duplication insofar as the terrain number appears in two data structures. So there is the possibility of a disjoint there. But that would create an error state, and that's okay, because then you would be doing it at design time, effectively, as opposed to runtime, like gameplay time. All right. But if it's a dictionary, then I'll need a way to translate a key to a texture wrapper. If I just have 3 lists and they're in parallel, that will work just as well. Okay. List of bitmaps will need a little bit of song and dance to get them loaded, because I'm going to need to load files in order to get them in. But if it's instead of a list of bitmaps, it is a list of texture wrappers again, then I can just load it that way, and then I can iterate over the texture wrapper and convert it into that list of lists, which is here. Okay. Live design here. Live stream of consciousness design. Again, if this were being done as a professional team kind of process, we would have a document for this. That document, as is universally true, would be getting updated constantly. It would not be a we define it at the beginning and we stick to it. It would be we define it early and then we change it as reality comes into play. The old saying of no plan survives contact with the enemy kind of thing. Okay, so this is a public list of texture wrapper. And this is textures. And we need a converter for that. Need an example of a list of textures. Where do I have a list of textures? I'm looking for a converter. Does world map already have one? Does map render have one hiding? No, it does not. I was just in world map. Of course, it doesn't have one. I was looking at it. Here we go. You. Okay, this is not a list converter. This is a IDs. We're going to call you terrain IDs. Okay. We're going to have you again. Call you map chunks. Map chunks textures. Then we have a protected list of integers, which is map chunks. Oh man, no, this is a list of lists of lists. Dictionary of integer. There. Okay, so we have a linear series. It doesn't need to be a dictionary. It can just be a list. Okay, so we have a series of integer grids, essentially. As the map is played out, the world map is going to be keeping track of which chunk we should be in, and it will be able to translate that to one of these grids that it can feed to the map renderer to say, here is a chunk of world map to load. In parallel, we should have a way to say this is a chunk to unload. And what that would mean is that we would hide that tile map layer, disable it, hide it, and have it ready for reuse. Get how many of them we cache is determined by how big we make the chunks and how far behind the player the you shall not pass wall is. For the time being, that is going to be the screen. Is you cannot go back, like the left side of the screen is impassable. We'll start with that. This guy is getting some attention here. Check some stuff. stuff. Okay. Okay. Then in a world map, we don't have any of this. Similarly, we don't have this, or this, or this, or that, or that. You or you. World map previously did some of the stuff that the map renderer is doing as far as creating the atlas. Map renderer. We're going to set a world map, and then we're going to get our create map atlas. Needs a okay, so we're going to we need to expose some of the things on map tile renderer because it needs to be fed information. Now, since the map tile renderer is reloaded when the game starts, we can, like when a game instance begins, that's when the map tile renderer is going to be loaded up. It is part of the game load sequence here. So when the game object is added to the tree, we go in and we populate it, and one of the things we add is the map renderer. Okay. So the map renderer will be clean when we have it in there. World state is the thing that will control most of that flow. So world state, we set the level that we're going to use. So this is, you've selected your, the map you're going to be on. You've selected your player. You hit go. We now load up the game. We need to pass which level you're going to load in. And then that will begin the series of events. So world state gets a level set. It loads in that level. And as part of loading that, it feeds it into the map renderer. Yeah. If it's not apparent, this whole sequence of events is largely being created from whole cloth at the moment. Terrain tiles, load tile set. So set world map is going to be our first thing. Okay, and part of creating the tile map layer currently is the whole flow here. But if instead we kick that off and set world map, and then when I am loading a chunk, we feed that in, it's going to have an ID to it. Once a chunk is loaded, the chunk has an identifier. That identifier is ultimately a reference to a tile map layer. That tile map layer is the thing that'll be cached and wrangled by the map tile renderer. So this is the thing that is going to start the create atlas here. That's the map atlas where we get a list of textures to load in. We're going to add a list of identifiers in there. I'm sorry, the list of terrains to use. Because that's what the map atlas cares about, is texture list and corresponding terrain. So we have a list of texture wrappers and a list of integer of terrain IDs. Now this will create a problem elsewhere because we aren't passing in a list of terrain IDs here. And tile map layer needs to be separate of this. Tile map layer is going to load a tile set, but that tile set is already going to have been made. We'll create the map atlas, we'll create the tile set. We aren't going to load the tiles in at this time. These get loaded into our set world map. Terrain textures and world map dot terrain IDs. And then load tile set would also have those terrain IDs as well. So it is going to have a terrain IDs. We create the tile set. And we are going to do for each. Whoops. Not for each. And that terrain ID, we add its source. And we're going to pass in our list of terrain IDs here as well. like that. Clumsy, clumsy. Just terrain IDs. Count. All right. So the create terrain tiles is the same. Okay. So create terrains, and that is terrain IDs. Terrains, we create the terrain tiles. Okay. Again, if you wonder what I'm doing, ask. There's a whole lot going on. Tile set, adding that terrain ID. Create the terrains. Setting tiles. This is going to be changed. Instead of setting the tiles, we are going to load a map chunk. That will have a position. It will have an identifier. And we'll have a corresponding unload. Okay, we'll continue after a quick break. I will be right back. And we're back. So we need a dictionary of tile map layers. Ember. Extra clingy today. You are extra clingy today. Int 2 tile map layer. Map chunks. Already loaded. New. We can just prefab that. Once we have our tile set, that should be all we need for the tile map layer. Mason did not get enough pets on my way back to the desk, so he is chirping down at my right. All right, so we need a... So we're creating a tile map layer. Currently, we are creating just the one. This will be a tile map layer. Okay, we're going to check and see if we already have an identifier for that. If it is in our dictionary, then we're going to keep it. And we're just going to say, here you go. So this would happen if we allow the player to backtrack and they can hit another chunk. If that happens, that means we are in an adjacent one, which means it won't be unloaded. So we'll just say, here is the one you're going to use. But that doesn't actually make sense. Void. We're still going to pass in an ID. Okay, move along, ma'am. You need to pick where you're going to stay, Ember. So if you look there, that's Sherbet on the bed. Visually, if you can get a good look at him, Sherbet has a very irregular pattern when it comes to the tan and white. It is much more modeled. It's still mostly tan on the back and mostly white on the underbelly, but he has kind of a collar of white, irregular white along the edges, like substantially irregular, and some more white on his face. It is especially apparent when you can see both of them side by side. that aren't going to load the textures that way. We are going to need to load the atlas from outside. Is our tile map layer.tile set. So we need a tile set up here. We're not going to create the tile map layer first. First, we would need to load the world map. So we create the map atlas from the content that the world map has. Then we are going to say tile set is equal to this. So we have created our atlas source, and our atlas source is only relevant for the tile set. Then so now we have that in place. Then we have in our map renderer, set world map update. Update doesn't need to happen. For one, that's handle message. Problem here. We are slowly converting any update call over to handle message. It gives us flexibility. It's update is, handle message is used to handle time past messages, which are the same as the prior update delta. But handle message also allows us to easily plug in a new message type if we need it. So we could have a load chunk message, but I don't think we need a specific message for that. Okay, so this creates these, then it will always be a child once it's created. In fact, we could create a series of tile map layers because we only care about what their identifier is. We can remove it from the collection as we need to. So we have a list of them. We have a list of available ones, and then we have a dictionary of active ones. So if map chunk stuff contains ID, if it's not already there, then we're going to make it. If it's already there, we don't need to do anything. Then from outside of this, we can have it return a tile map layer. Remove you, else. Okay. So create tile map layer will make one and load it into the collection. Otherwise, we will return the one that we've got. And we will set its position accordingly. So we set world map. We are going to have void load map chunk, and it is going to have an int ID and a the world map could have it as a position. Okay, so map chunks would be at fixed locations. In theory. But if we say it is this map chunk, put it here. So now the world state would be controlling from outside. We can control which chunk appears where. This will give us flexibility, because if we do things like we change the level to be infinite in length, and we are just saying, because you can't go back, we're just saying that we're going to pick a random map chunk and stitch it along. We could put a particular chunk anywhere we want. We can load as many of them as we want. So we could load, all 5 of the map tiles that exist, or the map chunks that exist, and just reuse them over and over within limits. But so if we have the ID, we have control over what we place and where we place it. It can cause some issues if you do this wrong. But again, that is my code. I have set up my code to do it wrong. So that's not really a problem. So then we go into our map, our tile render here, and we're going to say public override load map chunk. And we are going to say create tile map layer. And that is going to be ID here. Tile map layer position is equal to position. So this is a way for us to assert this is how big they are. Hey. We can control where they go, which can allow us to have a little bit of assertion in how they work. So for example, a chunk needs to include what the adjacent terrain tile would be. So when I'm making a map, part of the process of making the map is setting it so that it is slightly bigger than it should be. I'm sorry, each of the chunks is slightly bigger because all of the tiles there should reflect what I want them to be. So if I want to have the proper auto draw adjacency, I need to have that set up. Now I could have one universal tile map layer. And just set its position values accordingly. So we have a way to determine what the chunks are. And we still load them with the same concept, is that there is overlap, but I don't have to worry about multiple tile map layers. I kind of like that better because then we're not worrying about wrangling the individual tile maps and their possible overlap. We're saying this tile is the one that you want to set. Like this is the coordinate offset that you're using. It will mean map coordinate to tile coordinate overlap. But that should be okay. If we do this right, we don't have to worry too much about how we lay out the chunks or how big they are. They can be as big as we need them to be, or as big as we want them to be. Like I could have one chunk that is way longer than the others. We'll need to have logic of where that chunk would go, like how we align it with the others. But we could do that. That does give us some layout flexibility in how they work. Again, I don't need to worry about that overflow adjacency if I'm loading the chunks ahead of where the player can see, then the tile map adjacency should always update properly. Within reason. We'll have to check that. But the adjacency should update any relevant adjacent tiles each time we set it. Okay. I like that better. I like that a lot better, because then we only have the one tile map layer. And loading the chunk is loading those tiles in on the tile map layer. So the position is our offset. That is where the values will set. I'm sorry, that is how we'll adjust the value. So it will be that position plus the coordinate space that is in the actual chunk data that we load. Okay. So when we load up, we are going to create a tile map layer. We're just going to create the one. And we'll set it to be a child object. We don't need to worry about tracking the others. And when we're unloading a chunk, we can clear those values in the same fashion. So map chunks are no longer tile map layers. They are lists of positions. There's still a list of list kind of things. Okay, so we're going to keep tile map layer around. We're going to change this to be map chunk, quit that. List of int, close. All right, that's going to break some stuff. That's okay. Don't add map chunks. Don't have you. It is going to be similarly. We don't need to return. Don't need an ID. Layer, scale, tile set. We don't actually need to keep the tile set around, but I think that's okay. Because we can do this in sequence here. We set the atlas source that lets us load the tile set, which lets us create the map tile layer. We could have this be a chain of things, because once we have created the tile map layer, we don't need the tile set anymore. Tile set, tile set. Now we don't need to keep tile set around. We just have our tile map layer. Tile set. So then when we load a map chunk, we need a position that we're loading it at, and then we have a list of list integers. We will set this into the virtual here. So So in load map chunk, that's how we're going to set the tiles. Unload map chunk will get a need a int ID. Again, okay, so this is which chunk it is, where we're loading it. But the position does matter. The position of it matters. Similarly, it's convenient for us if the map chunk is just a list of lists. It is the grid that we've got. Doesn't matter how the chunk is, like where we've got it. We're saying this. If the map chunk that we save is actually a list of positions with their terrain values, that could work better. But as far as the process is concerned, there's no reason for it to be a list of integers. It could be a list of pairs. So it's a list of lists of key value pairs of... No, it's just a list of key value pairs. Ultimately pairs. An integer, a position, and an integer. Where that position on the map is predetermined. I'm sorry. If when we are loading a chunk, we're saying this is chunk X, it is located here on the map. We're going to translate this grid, what amounts to this multi-dimensional array, into a list of positions, We don't actually care what they are anymore, because when they're loaded, they're loaded. The map tile layer has the tiles there. It's irrelevant when we unload them, because we want to iterate over those positions again. It is a list of positions at that point that we are going to then unload as far as the tile is concerned. We're going to set them, we're just going to set the position, which will result in defaults being used on all the subsequent parameters, which will clear the tile. And if we're leaving one tile set behind and we're loading one ahead of where you can see, that means that we don't have to worry about the adjacency getting wonky. Okay. Okay. So this is a list of vector 2i. Hey, no. Actually, this is a list of... This is a vector 2i array. Nope, quit touching the mouse. It says, but I wanna. Okay. We are going to name you loaded. Come on. Loaded map chunks. Because again, once we have set this, we don't care about it until we're going to unload it. Okay. Okay, so we load a map chunk. Oh, here, we're going to move you down with the function that we said we were creating down here. Then we're going to need unload map chunk, which will just give us an identifier. Chunk. Okay. We're going to need in load chunk, we're going to need to account for if it's already there. Unload map chunk. That mouse movement was sky. Load map chunk ID. I'm watching you. Guy can be very chatty too. He's a sleepy old man most of the time, but especially once he's got his energy in him, he's chatty. He does, Silent Night. He does. Welcome, Silent Night. Welcome. To some extent, he seems aware that his name is Sky, but I'd also swear he thinks his nickname or his other name is No. Isn't that right? Troublemaker. All right, so we have vector2 array. Ugh. This is for each row. Chunk. Count. Plus. Now we do a double iteration here. X is equal to 0, X is less than Map chunk y.count. IntelliSense being useful. It has been not useful multiple times. Hey, buddy. But you can't rub your face on the camera. It says, I clearly can. Give him some back scratches. Like many cats, Sky has some coarser, longer fur along his spine. Notably, he has a little white stripe on his along his spine towards the back. He also has white markings on his face that give him a perpetual smirk. Like it's right along the lip on the left side, and it curls up towards his nose further on the right side. He's got very long droopy whiskers too. Okay, so for each of these, we are going to say oh, this is tricky. For this set, when we're setting the tiles, we need to get to here. So the set cells, it needs which terrain set, which is always 0, which terrain to set it to. So right here, we're passing in a list of lists of integers, and we're converting that into a list of terrains to vector 2i's. Sorry, we've got a combination of what the terrain value is, and we are pairing that with a vector 2i because we need to do each of them sequentially. So we need a list of a dictionary of an integer to a vector 2i array. Okay, so this is a combination of which terrain and a list of positions, the positions for it. Hey there, sharpshooter. Welcome. I'm currently trying to get our tile code map chunk loading set up. It uses a lot of what we got last time, but more so. This is terrain positions, contains key. Chunk. X. Top left is Sherbet. Top right is Mason. Lower right is Sammy. Mason and Sherbet are the tan and white brothers, and Sammy is the tuxedo. Not. What? You'll get it. You'll get it. It's not there. And again, terrain positions. Why? Okay, no, we were doing this right. So for each row, we're going to add XY. XY needs to be Y count, XY. No, 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 no. So this is, it's fiddly. Could I change this? Yes. But the way it is set up is that, again, I could set it up differently, but visually, when I'm creating it in a... Oh, but it doesn't need to be that way anymore. It doesn't need to be that way anymore. Excellent. X, 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 Y, 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 X, Y. Let's... referencing this repeatedly. We don't need to. Okay. The reason that we can make this work now is that we are loading, when we're parsing the texture that is the map chunk, we can go X to Y through it and get its coordinates. We're then going to load them in to a list of lists, and we can just declare XY on that. We are not manually entering a list of lists of integers, which would benefit from having a YX notation. We can control this fully. So as far as the list is concerned, we have its columns by row. But as far as our representation is concerned, it's an XY grid. Okay. So this map chunks X. Okay, so now we have created our terrain positions collection, our list of int to vector 2. Now we are going to set our tiles right here. But because we already have the list, our list of int to our dictionary of int to vector 2 array, we don't need, we're going to have u as a parameter of this. We don't need to create it. We have just done that. So we have terrain list. We're going to iterate over it. We're going to say set tiles. But as we're loading this, it's important when we're adding this vector 2 here, there's a little nuance here. Plus position. And this position is a vector 2i as well. And in our map render, that should be a vector 2i. So this is us saying this is the grid position that you're going to start in. So as far as the map chunk data, we could simplify this even further by having the dictionary of, we would still have to parse it and add the positions, the position into it. But we can have already a list of a dictionary of terrain ID to vector 2i lists of positions, because once we have loaded the map chunk in, once we have loaded the bitmap in our world map, we know what a terrain chunk is. Our map chunks. Those map chunks are fundamentally, they are lists of terrain IDs to positions. The only thing that's different is when we are going in and saying this map chunk goes here, we're offsetting it. So when we pass it in, we're giving it that offset. And as far as the world map is concerned, when it renders it, it accounts for the offset. So when we are creating our list, we're actually just iterating over it. Yes. It's coming together. Dictionary of integer to vector 2. We need the same thing. I think it's fine for this still to be a vector 2 array. I think that's still fine. I declare it to be so. is a list of those. We are going to need a translation between which chunk is where in the world. So this is the idea of a loaded chunk. And that would be a mapping of a chunk ID to a actual map chunk. Like a sequence. So we would have our loaded list, which is a list of IDs. ID position mapped to an ID. Dictionary. We don't need a chunk no, we need a chunk ID for this still. Because there is a sequence of them that is part of the map. Okay. Then, because again, I can repeat them. There's nothing about a map chunk bitmap that is, truly unique. I don't have to use... I can use the same one repeatedly. So I have a list of which chunk is there. But that list is going to be I need some logic as to when I load a different chunk. So it needs to be a list of them. It's going to be a pairing of a position and a chunk ID. Because then I can translate the sequence of them into a series of positions. Got to be some sort of memory leak in VTube Studio. Anyway. Okay, so I need to know what map chunks they are. What map chunks there are. Which will be a sequence of them. So first I identify what my map chunks are. There's my list of textures. Then I've converted that into instead of a list of textures, it is a list of usable map chunks. So here is the thing that we're going to use. Then I have So the question becomes, how do I know which chunks to unload and when? And that's going to be handled by the world map. So the world map talks to the tile map renderer. We'll move initialize into some sort of handle message on this. Once I have loaded a chunk, if chunk sizes are known, then we don't need to worry about the position. It's a sequential thing. I know that if I am on the third chunk, this is where it is. Okay. So then I have a public list int So this is us declaring as well that the map chunks are linear. If I want to do a grid of them, this is going to have to be updated. Could I do this? Yes. But it makes the logic for chaining them together trickier. Given that I want to have linear levels, now within the chunk they don't have to be linear. I can make it so that that chunk could have map tile collision in it, that there is a collidable map chunk that is loaded in over top. And we can do that in some element of it. It could be another part of the map tile, and that one collides with the player. Such that you could have like up-down movement restrictions kind of stuff. You have to weave around parts of the map. For now, we're not doing that. So when we create that, we don't need to copy this element. We only care about these. Okay. This is actively functional. This is reference. It will be passed in according to this. Terrain IDs, terrain colors. Once the thing is loaded, we don't need to worry about it. But okay, when we load this in, when we copy it, we don't have to worry about initializing it. We can say that it's initialized. If I have gotten this far, it is initialized, if I am copying it. If I'm not copying it, it needs to be initialized in the first time we interact with it. When it gets an update, that's when we are going to trigger the initialize. apply if not initialized. Initialize, and we are going to return apply because we ate that somehow. Say initialized is equal to true. That, so we have our map chunk sequence. Each a comma vector 2I array. This is a map chunk in this needs to be public then. Is world map. Initialize it. Chunks not add. New. So we add a dictionary of int to that. Zoom out. So we now have a map chunk. So this is for each value pair, which is an integer, which is a vector 2 array. Terrain position. Map chunk. Okay, for each of those, we are going to say map chunks. That's it. Our copy chunk. Chunk. This is a dictionary of vector 2 array is equal to new Dictionary vector2 array. Need to give it a name. You are going to be map chunk. Add map chunk. Let's see, map chunk dot add. Position. We just we're going to copy it in terrain. Position value. Okay, so this is us duplicating all of the map chunks. Which is all we care about. We have the sequence and we have the chunks. In this case, we have to actually create them. In map. Okay, so we're going to iterate over all of the pixels in the terrain. The terrain bitmap. And we are going to words and things. We are going to create this this dictionary here, and then we're going to add it to map chunks. Map chunk textures. So now we have a chunk texture. Call you chunk texture wrapper. Texture 2D. Texture. To chunk texture wrapper dot texture. Is less than width in pixels. Plus. And we do the same thing for Y. Height. We need the list of colors in terrain IDs to copy. In terrain textures. All of this needs to be copied as well. Oh, no, it doesn't. No, it doesn't. Because we've already got this. Oh, but no, we don't. We always need to initialize. We're going to chop that. We're going to copy the chunk sequence. Map chunks needs to be generated. Oof. We have the bitmaps loaded as textures, so we're not worrying about duplicating them. All right, we need the whole mess. We need the whole mess. So for each texture wrapper, services.catalog.copy. So we add those, then we have okay, so this should duplicate it. Colors should be the same thing. New list of color from map.terrain colors. Then we duplicate the chunk sequence, which is still an int, so we can just say that. Map chunks being much more complicated, so we'll leave that as is. Then we are going to call initialize here. Because since we're copying it, we can initialize it right away. We don't need to initialize the first one. Okay, if so, map chunks has to be defined elsewhere. So JSON ignore. You can never be loaded manually here. Means we can change you to be a protected, which means we don't need to JSON ignore it. We have to generate this. Because the first one is just going to have the bitmaps loaded. There's no point during the JSON constructor where we are automatically going to have all of the data that we need with certainty. So we can initialize it during the copy because the original doesn't have that information. I may need to have an initializer in the catalog load sequence, where upon it being added to the catalog, we call an initialize on the variable, because that would make this much more efficient. That said, for now, we're going to work with this. Okay, this is iterative. You want we're going to map the terrain colors to the terrain IDs. So we're going to create a dictionary from them for this purpose. Dictionary is a color to an int. Each color I is 0. I is less than rain colors that count. I plus plus. Mapping dot add rain colors I, then rain IDs I. If texture image so this is the actual image for the texture. If we say if chunk image dot is there a way for us to get data? Maybe it's get data. Nope. Looking for a way to get a pixel based on that value. think we may be operational. Okay. We did have an OBS crash. We'll have to see what is going on. But I'll have an error log for that, so we'll see. We'll see. Oops. Okay. So what were we doing? Let's do a quick search here. I don't know. OBS blew up on me. There's any number of things that might be happening. We'll have to see. Doing a quick search. Get pixel. Okay, this is part of image. Get pixel. And we can pass in a vector2i or an xy. Okay. Okay. Get pixel xy. Okay, we get the image and we need chunk image. Care about the image that comes out of it. Then if terrain mapping contains key color then we need to add to our vector2i for map chunk. This is equal to new that. So for this map chunk, so now we have a terrain ID. If map chunks contains so this is going to be chunks add to that color. How have I been? Pretty good. Our start earlier streaming schedule, I think, is working for the most part. There have been, still the same snags, but I found that I have been, by starting earlier, I run longer more of the time. We have a terrain ID. is a dictionary here. Just map chunk. So, hey there, Laura. I see that you have been working on your game as well. Well, thank you, Tanashiro. And do feel free to lurk, folks. If you don't want to converse and you just want to listen or watch, that's just fine. We're making a game, Tanashiro. We're making a game that's kind of like Vampire Survivors. And we have that map chunk. So if map chunk is key ID not chunk that add rain ID new vector 2I then rain ID add new vector 2I x comma y. Okay. Okay. So this you are rapidly learning the life of a programmer, Lore. Mumbling invocations to the machine spirit as you type. I mean, ultimately, when the machine spirit answers, it's telling you, nuh-uh. Um, so occasionally, more experienced programmers will swing through, and sometimes they'll say things like, there's nothing wrong with C++. And I agree, there's nothing fundamentally wrong with it. It's that at the level that you're interacting with C++, barring library layers that you could put on to protect yourself, which at that point you're using a higher level language. You might as well use the higher level language. But at the level that C++ works in, you don't declare an array just to say, oh, there's an array, I'm going to add things to it, or this is a list, I'm just going to add things to it. What you're doing is you're creating chains of pointers, or you are allocating memory of a specific size in order to fit a series of values. And if you mess that up, your program going to have a bad day. And the error that it's going to tell you is usually segment fault or something like that. Or like access violation or something where you touched memory you weren't allowed to. And then you have to go hunting for that. That kind of thing is the reason that we have government entities begging big programming companies, specifically ones that handle things like security and routers and web APIs and similar, to stop using low-level languages for some of their stuff. Because if you aren't fully conscientious about what you're doing, it opens the door to things like string injection attacks and the like. It is still so accurate. You have the person just getting started with programming, and it's like, it's magic. And then you have the person that's like really getting into it, learning exactly how stuff works, talking about this is how the compiler actually interacts at the machine code level. And then you get usually to the jaded, very senior developer who just looks at you and says, it's magic. I am past the point where I really care about what it's actually doing. I'm fine to let it do what it wants do. And am willing to discuss it in terms of it being dark sorcery. Okay, so by the end of this, we have generated the raw chunk data. Hurrah! So again, doing this has told me it would be very convenient if catalogables had a initialize call, that once they are loaded to the catalog, I poke it and say initialize yourself. That way, when I create a copy, if it has that kind of thing, then it can duplicate that relevant information as opposed to duplicating the raw data and having to rebuild it. I have known a lot of people that have things like this terrifying Word doc or Notepad, Notepad++ instance open that is just dozens and dozens of files that contain the accumulated knowledge and trickery that they use to get by in their day-to-day. Put another way, I was absolutely shocked to encounter a technical lead that had not heard of essentially the hit by a bus scenario. And that's, what is our plan for knowledge recovery if this person is hit by a bus tomorrow morning? And for most of the folks, it's, well, okay, we would have to devote the entire team to looking at the gigantic catalog of esoteric notes that that person kept about all of their different responsibilities, systems, and like macros, and hope that we could parse it, because if we can't, we need to start over and rebuild their knowledge. Which means you won't. It will become a constant game of catch-up. Which, for reference, is the entirety of this code base. I don't trust this kind of indicator. So it's saying, well, you don't need to do a new list. You could just set equal to this. I don't trust that. This is a by reference. I don't want this list. I want a copy of it. The trick with things like Excel files in the spreadsheets in them is not that you wouldn't be able to use it. It's understanding why in a particular column you have a weird string parse on, say, like the date time, and you merge it with the computer name in a particular fashion, and make that part of the view that results. And a person might look at that and say, that's nonsense. Why would you do that? We don't need that in the sheet. But they don't realize that the reason that column's there is that that data value needs to be pasted in to a corresponding web API that will then spit out a value that you need for the real view. And if you don't do that, you know, your servers explode. Exactly, Lore. It's what is it called? It's somebody's fence. There is a kind of an adage or a truism that is, you encounter a fence out in a pasture, and you don't know what the purpose of that fence is. Do you step over it or do you tear it down? And the intent of the system, or of the question, is to say, effectively to say, if you don't know what it's for, don't get rid of it. Learn what it's for. Find out what it's for. Because if you break it, it's broken. And you might have to deal with the mess, let alone rebuild it. But if you learn what it's for, then you can make an informed decision. And for most companies, we don't have time to learn what it's for. Just get rid of it, or just let it be. Just leave it alone. That's how we get load-bearing comments. Okay. So with this in place now, we have the concept of a file that upon being loaded, it's going to have a bunch of texture wrappers. And it's going to have terrain ID, Chesterton's fence. Yes, there you go, Laura. That's the thingy. We have a triplet of linked of parallel lists that are texture wrapper to terrain ID to color. What that is to say, in this texture, in this bitmap, it's that kind of thing, Lore. Or if you don't know what it's for, don't break it, or don't get rid of it. So we use that set. Hey there, Vibex. Welcome, welcome. We're designing a process for converting a bitmap into a tile map layer in Godot in a format that I can cleanly edit. And then we shall present it within the game. At the moment, we just want to get it working. Okay, so I have the chunk textures. I have the terrain textures, which are part of the terrain IDs. Okay. The chunk textures are... yes, those are 3 of my 6 cats. Upper left is Sherbet, lower left is Mason, and lower right is Sammy. We haven't checked for the kitties in a moment, so let's do that. Okay, we have all 6. Molly in front and Sky in back of the cat tree. And then Ember is laying down in jackknife position there across from the keyboard. She is toasting on the heating pad. Okay, and then once we get it loaded, we are going to convert the textures, the image files that represent what a map chunk looks like, into raw data that is collections of terrain IDs, which we get from up here, into lists of positions. This is used later when we are rendering the map, because when rendering the tiles onto a tile map layer, where we have auto drawing to create connections between the tiles, we need to supply it with the terrain ID, the tiles, kind of the tile sheet to use, with a series of positions. Okie dokie. Save. Do a quick build. Oh, no, it exploded. Time passed. Message. Time passed. Right arm is starting to act up. There. Build. So what I'm doing right now is I'm ripping all of the insides out of some prior code that we had. I'm going to revisit this, maybe. So what we're working on right now is using the Godot tile map layer, because it allows us to accomplish something at a potentially lower cost. As far as like sanity is concerned. But it might not be efficient enough for our purposes. The code this older code here that I would need to reformat is uses the shader the GPU directly using a texture shader that we would put in place to handle the rendering. We know that pattern works, but I would need to update it to handle all of the song and dance of tile adjacency. And if I can avoid that, I want to. If not, if the performance of this structure is bad, then I'm going to need to revisit the shader pattern, which is not great. But we've got the general shape of it. Mental health / self-care is a big part of healthy living. And getting engaged with a complicated program has a, like, it taxes you in some fashion. It's either you're keeping a lot of plates spinning or you're losing track of things. Both of those have some degree of stress. If you're losing track of things, stuff starts breaking and you don't know why. If you are spinning a lot of plates, you're keeping a lot of balls in the air, whichever metaphor you would like. It is the constant stress of keeping things going and not messing up. I've got a little both going on. Okay, so we are going to do an interim here. Yeah, stress is sanity damage. Take too much of it and it's team kills all the way down. Quick break. Be right back. And then we shall resume. And we've returned. How long will I be streaming for? Probably another couple hours plus minus. Assuming we keep the same momentum, might be a little longer. Okay, so now I have world map in place. And then in map tile renderer, okay, so for world map, what we can do is upon receiving our first message, we are going to load the first map chunk. What? Map chunk 0 is going to be at new vec2i at 0, 0. And it is going to be map chunks 0. Okay, and we need to update load map chunk to accept a dictionary instead. Okay. Dictionary of integer to list. No, it's a vector2 array. Map chunk. Int to vector2i array. Map chunk. Okay. So now we have all of this stuff, which we don't need to do. Boop. So when we set tiles, we're going to go through each one of those, and we're going to call it with the int pair here. But for this one, it's going to be a little bit different because we don't care about an integer. We just want a vector2 array here. So our loaded map chunks again, we only care about positions in loaded map chunks. So this is a map chunk ID to its positions. Okay. So we set tiles. Come on. Come on, bud. Okay, so this is make you. Hey there, Hayes. We are expanding upon our tile map logic and getting it closer to real. If we create the offset, then Ember being cozy, yeah, Tass. Okay, if we create an offset, so let's... So this is where we'll update the positions. And as part of it, we are going to create just the positions here. Chunk. Say vector2i array. Ugh. Nope, that's still okay. Each. This is a key value pair. As per usual, do not feel like you need to understand what I'm doing here. Value. Value, so we've got a terrain position, it's offset position, add terrain position, plus position. Loaded position. Position is equal to that. Now we have the offset positions. Now we are going to say offset chunk. Add where.key offset positions. And then loaded positions need to be copied in. Okay, so loaded position is aggregating every position within the chunk. Because loaded positions does not care what they are. So the offset chunk gets its key value pairs updated to be adjusted by position when we put the chunk there. Okay, and then we set tiles on the map chunk. So when we unload the map chunk, contains key ID, then we do a thing. Okay, so this gets us a loaded positions. So loaded map chunks.add, which is ID, which is the chunk that we're adding, and then loaded positions. Dictionary int iArray to unload is equal to do that. To unload add. You're being very squirmy, Sky. He's on my lap and he keeps kicking my arm. He's rolling around. Sky being sleepy is the only time that he drifts towards slit pupil. Most of the time he is full wide-eyed. He's taking it all in. Add -1. And that is loaded chunks ID. Okay, so we are setting the terrain to -1. If you do that, it erases it. Right here. So we're saying, okay, which positions are we setting it to? If we had a marker in here. I think this will work. Given his behavior, you'd think Sky would like kicker toys, but he doesn't really. For the most part, none of mine do. Set tiles, and we are going to get to unload. There we go. One might have a dozen the other. Okay. So when we unload a chunk, we are going to go through and purge it out that way. We're going to see how this do. Right now that do nothing. To get this to work, now we're going to need to update world map. Okay, so now we need to get to our data here. Data folder. Which one is a world map? There we go. So most of this is irrelevant now. All of this is irrelevant now. Actually, world map needs to be a JSON now. Something loaded up here. It's going to say world map test. Okay, we need our example one open again. Right. Get our format correctly. This is a world map. Hey. All right, let us proceed. So our terrain textures are going to be our same set that we were using before. These little guys here. This creates our atlas. comma. Grain IDs. List of integers. We're going to say 5 and 9. This one gets a little trickier. Is an array of color objects. I need to do a quick test on what a color has. Should have RGBA. Yeah. Which I believe are 0 to 1. Okay, they are floating point values. We are going to say 255. And we'll leave all of the others at... So then A is 1. 1. And so that one's red. This one will be green. Blue. Then there's our colors, our map chunk textures. Going to be a list of texture IDs, which we are going to have to load in as textures. And then our map chunk sequence. It's another list, which will have, we're going to say 0 to 1. Say 1, 0. Back to front. Okay. This should be the data structure for it. I need a map chunk, 2 map chunk textures. So just a second here. Get a kitty. Save that. We are going to go into texture. We're going to get a map texture. Map. All right. Let's get rid of all of these. Delete layer, ember, 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 ember. remember. I know. She gets some ear scratches and some back scratches. If you climb all the way up on my shoulder, you're getting down. You can lay on my shoulder, but you can't stand on my shoulder. Alright, so we're going to do sprite, canvas reset. No, sprite. Canvas size. Okay, multiples of 16. Let's make it 20 tiles tall. So 320. And we'll just do 320 by 320. Just so. Actually, let's do a quick little sanity check here. We are going to do 5 by 5. 80 by 80. Actually, no, that's even... Sprite, canvas size, 5 by 5. Yeah, we can do 16 by 16 in that regard. That's plenty of tiles. Okay, we have red, blue, and we are going to edit U, and we are going to change this to RGB. Where is it? That. Red is 0. Green is 255. And alpha is 255. And then we're going to edit U as well. And U. U and there and zoom. That. Okay, so we have 3 textures. Our first one, our red. Red, green, blue. So we are going to do little blocks. We'll adjust that in a moment. Anywho. And we will border it in like this. Just making it real apparent. Which ones are which. Chunk 1. Zero. Okay, then layer 2 will start with blue. Have a nice that. Am I doing it this way because I want to? They are real different. And we have that. So we are going to export this as world map test chunk, number. I think PNG should still be safe for us. This is 0, 1. And this is 0, 0. So we could have this itty bitty guy here. Okay. So then if we go into texture wrapper, let's look at the class for that, because we might be able to just define it right then and there. Instead of this, because chunk 0, 1 doesn't need to be anywhere else. But we'll see. In this game, where are we keeping textures? Texture wrapper. That is entirely... we should just be able to pass in... Load a texture wrapper. We're using a texture name converter. And the texture name converter should be in our JSON, which is the file path. Okay. So if we give it a file path in texture, I don't think we need anything else. Yeah. So with this, we can have one of these, which is a type. Wrapper. As a texture value of the path. Is structure that. Duplicate. It's map data currently. Nope, nope, nope. It's map. Okay, so if we take that for now. These are in. They are in map. And we're going to do chunk 0, 0. One. Okay. In theory, this should load in a world map. Okay, and then in our level, we have our event list. If I just manually force it at the moment, I can just tell it to load a chunk. Here, when we do a handle message into the world map. If I go into game, at some point we are setting the level. So if we do services.map render, our render dot set world map is a world map. Services.catalog dot get catalogable. Calling it map test. That. We are just going to do map chunks 0 for now. And it will be at this won't work. World map has a lot of the pieces that we'll need. Okay, world map can get any sort of message. Okay. Hackety hack, hack, hack. Whole lot of interim code going on. An abstract. All right. Build. How do you fail? Go into our world map. We're going to go into our copy process here. We never go into the copy constructor. Nothing from today. Sorry. Stack here. Line 103, we set the world map. Okay, let's break there. Okay, locals world map is null. Mass test. Let's double check. Ah. JSON. There was no such thing. over to texture wrappers. Those texture wrappers should be a thing, but the world map that we're copying doesn't have any. We are passing terrain textures in. Right there. A list of texture wrappers by ID. Which expects a list of strings is what it's going to get. And it's going to convert them over manually in that regard. But this also implies that we're not going to be able to get those bitmaps in. Ultimately, we don't need them to be texture wrappers. We need them to be textures, but that doesn't solve the problem. Texture wrapper helps us solve the problem. But texture wrapper is kind of functionally bloated right now. I do need to have a difference between texture wrapper and like sprite wrapper kind of thing. Why is that not coming in properly? And I expect that it's because we've got this converter here. Let's try without this. This one we'll leave it. We can reuse these. These are level specific for now. Let's actually check our error folder here. Okay, we're not getting any JSON errors. To copy is like nothing. It contains nothing. Map event list is an object. And it contains a list of world map event items, which are properties, and since they're not properties, they're not being loaded. Oops. Once more. Better. Okay, nothing came through in that. We need to figure out how to properly enter a color value. Second here. Try that. Over here, and instead of this, heck. Alpha RGB. Good old Stack Overflow. Let's try that. 5. So this one is red. Okay. Thing. We're going to go into our copy constructor here, and we're also going to check our error logs, which we have one. It's Godot.color. Okay, let's make sure that we've got this right. Let's see if we have another example. Nope. Okay, so that's not how you serialize a color. Let's We are going to go into world map. Here should be where things will break down. Try to get this far. Oh, that's right. That's not how it serializes. It'll pitch a fit. It'll never get that far. Boop. Okay, color. So now we're going to go into our immediate. I wanted. Say color dot. Serialize. No, no, no. Let's try in parens here. Check our error logs again. We failed again there. That's toString. How can we decipher this? I could write a converter for it. In theory, this would work. Like that. We didn't get a new date modified. Here we're going to start. Okay, so now we're looking at world map. So now it's 0, though. And I just do it as not going to like that. Be okay with that. Our error log, we did get an error log. Can parse it. Because we are getting a color object when we do this. And can I wrangle this as well? So we're going to go up into texture wrapper. We're going to go into the JSON helper for texture because that should have Godot, okay? So we are just going to jump right in here and say color dot red is equal to 1. Color dot alpha is equal to 1, and we're going to set you to actually 0.5 just so I can differentiate. 0.5 float. And we're going to get all the way down to here. Could really look at catalog, but serializer.serialize color. Don't know what we were missing. Because that is the form that it's serialized in, is that. Go back into our world map. Still 0. It's still not loading that in. Oh, okay. Okay, that's right. That's right. It's actually 8. Okay, let's try that again. Interesting. This is in our copy. Map chunk textures is empty. It's not being converted over. colors is. Colors is. So we are getting our values in there. Okay, so the map chunk textures aren't loading. And map chunk textures are texture wrapper with the texture data there. So let's check our error log, which is not recent, so we are trying to load it in. Map chunk textures, if we use a name list converter, it's going to come in as, it's going to expect it to be strings. Texture wrapper, and they do have a texture. Okay, the copier has the texture. Okay, so there's just a logical error here. So when we go into... Oh, we're never copying the map chunk textures. So it's a new texture wrapper. Each. Textures add texture services catalog get catalogable is no copy. Okay. Closer. Okay, nothing happened, but closer. Okay, so we're going to go into world map, handle message here, so that we get that initial trigger. Initialized is true because we finished initialize here. Okay, so this is the only time we're going to do this. So the only time it receives a message. Okay, nothing happened. Let's check it on the Godot side. Godot will emit Godot engine errors that the C# side won't report. Okay, we do need sequential terrains. The color values and those need to match. Okay, that's still reasonable. So the terrain IDs should match this sequence. So we're going to have to go in and we're going to rip terrain IDs out because those are an assumed thing. Do. Boop. Okay, we don't need... We still want to do this mapping. Okay, so this is going to be count. Actually, no, it doesn't need IDs at that point. Okay, so we go to Atlas. We're creating terrains. That's where we have our textures. And we're going to say textures.count here. Then when we go to create terrains, we have an int terrains. Terrains, less than terrains. We're reverting this more or less. Okay, and we're gonna go to you, and we're gonna say nope, we need an integer terrains. Terrains plus I. Count. No. Run you. What's going wrong? outside of the texture or already present. It's in Tile Atlas source where we are at create tile in 264. Map tile render 244. This is in create terrain tiles. Strings, terrain. Yeah. Three terrains. So terrain is 0. 0, 1, and 2. Then terrain 0. Okay, we loaded that twice. So that's going to create a problem. First time. Oh, it only went in once. But didn't it say there was another? This could be our problem here. Won't create terrain tiles, right? Create terrain tiles. And then we're calling into create tile, so at 244. Right there. Okay. We are either out of bounds when we're creating the tile set, or check a couple of things here. Okay. All right, let's we're going to run all the way to here. So we have our image texture. We have our Atlas image. Get height 6. Is oh, okay, that's right. We are just saying max it out. Okay, so it is correct there. Going to create terrains. Inside create terrains, we're going to create terrain tiles. And here. Zero, 1, 2. It should not be doing this twice. It shouldn't go through the whole set. Oh, no, okay. That is... But terrain is resetting. Are we doing this? We have an extra initialization going on. We call set world map. There are 2 references to set world map. One in game and one in map renderer. Okay, that's the definition of it. This is where... Why would we get this called multiple times? That just happens once. Tile map atlas. Create tile map layer. And game ready. Still in game ready. Happens a grand total of once. How are we getting into that multiple times? Breakpoints. So it is create tile. So row column terrain. We are calling out of game ready, so we have set world map all the way up into create tiles. So column. So now we're back around and we're still in ready in set world map. So this is the second time. Could have just started it again, gotten the same result here. Bro, we are currently trying to figure out why it's double loading the tiles. We shouldn't be getting multiple instances of the same terrain getting invoked. So this should be causing us to bail out. It's our another way to put it is our create terrains seems to be getting called multiple times. So we start. So we have create terrain once. We have create terrains twice. That is not correct. That is leading to a Godot error that prevents the thing from being set up properly. So we do set world map. So we just hit create terrain the first time. That makes sense. Now we go again, and we're back around in create terrain. So why are we here? Go in. Step over you. That's why. Okay. Creating the atlas is resulting in create map atlas. Merge it. We create terrains right here. That's technically true, right? Where is create terrains called? Okay, there are 3 references. One is in here. Load tile set also calls create terrains. But that's where we add the terrains. Atlas shouldn't be doing it. It's textures.count. We were double loading the terrain tiles, so it created a Godot error because we had already specified that moment here. Okay, it's still not going, but let's see if we have a fresh new error in Godot. Okay, no errors. We're doing better now. That doesn't mean that everything is functioning, but we're closer. Right now, we're trying to make sure that we're actually hitting all of the flow of logic. We don't know that it's actually invoking it wrong yet. We're just making sure that everything gets hit. Okay, so we go into our game flow again, where we are setting the world map and then we're giving it a time passed message. So by here, we should be setting the terrain tiles. So we're going into a time passed message. So we're going to load chunk 0 at 0, 0. So looking at chunk sequence has 0, 1, 0. Map chunks has two things. We're going to load chunk 0. Chunk 0 contains nothing. Nothing. Okay, so our problem is we have nothing to load. So some part of our terrain chunk parsing as far as the color is not correct. Okie doke. Okay, but this color should be in all of them. Let's double check. Ha, it's not. But let's make sure here. So we are getting an image pixel. So this is a red pixel. And our terrain mapping. Oh, okay, we didn't set it up right. You are 255. Nothing matched, so nothing would be drawn. So that's red, green, blue. Do. In, step out, step in. We are stepping in. We're going to look at map chunks. Chunk 0, raw view, contains nothing. Okay, we're still not right. But that means our map chunks haven't loaded. So now we need to go into here. So once again, we need to verify that we're getting the right colors out of the process here. So we have red, and our terrain mapping has red. So we're going to hop in, Our terrain ID is 0. We do not have a vector2i array for that. So we're going to add that in at chunk. So our map chunk has one thing, which has a 1 into a collection of nothing. Okay, and then we are going to add that to that one. We're going to say our values 0 contains 0, 0. So then we loop back around. And we're going to get our next color here. Womp womp. That is the rule set APT. So I don't remember where it shows up. But anyway. But anyway. We are just gonna boop. Tacky tacky. Okay, we're gonna run it again. In, step out, step in. So now we are going to look at our map chunks once more. Chunk 0 contains many, many things. Say 16 by 16. Odd that the subsequent chunks... Where are those loading from? There should not be that many map chunk. Because, I mean, this is correct. But what with the other chunk? Oh, okay, I know. So now We have 2 chunks loaded. We are going to say in world map. We are going to load this one, and then we're going to load the next one at, this is going to be 16 at 0, and we're going to load 1. Okay, that failed. That failed. So if we go into world map, not have map chunk textures should both be loaded. So we are going to look at this again. Okay, so we get all the way here. We load this in. We check map chunks. There are 2 map chunks. Okay, that makes sense. Yes, over you. Oh. Okay, let's run it on the Godot side and see what it's complaining about. Because it's got to be complaining about something when we do this. It's just a matter of figuring out, well, we run it on Godot to see the Godot side errors. Okay. An item with the same key has already been added. Okay. One. Okay, our offset is not functioning, but the logic for creating the tiles is working. This is good. Yet. Okay, so when we are sending them in, the load map chunk, which is in tile renderer, when we load the map chunk, so our offset positions, we create the position. So we're taking this as an offset. We add them together, we get an offset position. Offset chunk. Set tiles offset chunk. Okay. We now have a relatively clean way of creating maps. We can just do like pixel by pixel settings, like a grass tile is green kind of setup. with each map having its own listing here. Okay, now we're going to test unloading the chunk. So if we go up to our world map here again, we are going to say this is .unload map chunk. Okay, this should leave only the second one now. Okay, now we're going to do the same thing with the first one, or we're going to leave the first one and remove the second one. Oh, very nice, very nice. Okay, I think that's going to wrap it up for the day, folks. We are. I think I'm at that limit before I toast my brain. Oh, dear, dear, dear. Okay. So we got the rendering in place here. We have the ability to create a map chunk. We have a way to define a world map as a series of chunks. We have a way to render those chunks to decide what they are based on tile sets. So we say, here are the tile sets for this map, or here are the tile sheets for this map. This is a map chunk color pairing with them. We create a bitmap composed of those colors, and that becomes a map chunk. Whenever we're loading map chunks, we feed them in based on a sequence. That sequence currently will be a left to right sequence. It's as you're moving along the world, you encounter the new map chunks. This is just editing the one tile map layer. The next thing we need to do is orchestrate this full load up, where we say, okay, the level tells you which map to load. Load that map. And that map gets told or monitors where the player is or similar to update itself. Now, whether we have the map render ultimately do that or whether we have the world map do that, we'll see. But we are at the point where we can create a world map conveniently create a world map and then see how it looks in the game. We still need to finish entering all of the information of a tile map or a tile sheet. If you recall, the last stream, we sort of stalled out trying to decide which parts need to go in there and which don't. So that might be something I try to do before the next stream. We'll see. But with all that said, folks, I hope you had a good time watching with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all of that good stuff. It does help the channel grow. If you'd like to consider financially supporting the channel, you can do so through platform-specific means as well as Patreon, Coffee, Throne, that kind of stuff. Links to all of my sites are in the link tree that is in the description and in my in my bio and in the video descriptions. Words. And And with that, I do hope the rest of your day is good, and I'll see you next time.